I carve birds for a living, and I love carving birds in flight. In every wing position, every wing beat has a power stroke and a recovery stroke, a power stroke and a recovery stroke. And a bird doesn't particularly like to be in recovery because there's no lift in that wing position. They like to get through that as quick as they can so they can get back to the power stroke. But in carving and pursuing birds in wood and birds in flight, I discovered that that recovery stroke, to me, had the most grace and beauty in it. Yet it was the weakest wing position that a bird could be in. I was approached by the Hollins Cancer Center down in Charleston probably 5 years ago. And they commissioned me to do a sculpture for their for the main hall in their cancer center. And they asked me about some of the ideas that it might have, and I showed them the idea of recovery stroke. And since hospitals are all about recovery, this tended to strike a chord with the Hollins Cancer Center. And as a result, I carved and sculpted a smaller version of this wing. And once it was installed, it captured the imagination of some of our city fathers and interested persons in Sculptor. And they wanted to commission me to do one for Swan Lake. Now, the wing that I had done for the Hollins Cancer Center wasn't but 6 feet high because it was an interior piece. Now, Swan Lake being outside garden, beautiful garden, that 6-foot scale was not going to work outside. We actually took the 6-foot wooden original out to Swan Lake and proved to everyone that it just wasn't going to work. So what we did, we backed off and backed away and determined the height that the wing needed to be, the sculpture needed to be. So it turned out to be twice the size of the one that was down at the Hollins Cancer Center. So with that, the Beatties, with their computer skills, they were able to scale up what was already in their computer and cut out this wood original that's behind me.
The process right here, the very first step, is to take one of Grainger's original life-size feathers and get that into the computer. What this machine is capable of doing, it has a point, and when that point is placed on an object, or really anywhere in space, you have a foot pedal switch that will capture that XYZ value for wherever that point is. So by working around the perimeter of an object, you are able to capture points in space all around that, create a perimeter, and then by capturing points out on that surface, you're able to create a surface. Those are mathematically correct, and they are stored in the computer. You can manipulate those, you can scale them up, scale them down. Once he has created those surfaces, that feather has to be placed in a block of wood that it's going to be machined out of. When this tool path is created, it's created based on the exact piece of wood that the feather's going to cut out of. We need to move out to this router because that's really where our expertise is on this CNC machine. It's amazing to see what they do. this same grid is in his original drawing. So when he places that wood block in his computer drawing, he places it on this grid to match. That's how you know the block's in the right place. And all of these are marked with center lines and these little brackets on the center lines. I've already machined the other side, and so when this comes out, it's finished except for Grainger cutting around the perimeter.
Now we have the basic shape here to begin the process of detailing this. You see how thick it is, and I will start the process of putting some detail on this. Put the vein in. I've textured the feather. I love wood. There's going to be some wood texture picked up in the metal, and also some cross hatching here that's going to also come out in the final feather casting. Just to add contrast, I'm going to come in and put some fine lines in here, just a few of them, and just to add a little bit of separation from the texturing I was doing earlier. So much of this is going to be hidden because some of these feathers are going to be overlapping and won't be seen, but I still feel like I need to do it. You noticed earlier the metal tab that I had on this to hold it together in the model piece. Actually, we've enlarged that to this, so that this is what's going to be this metal tab is of course much larger and is going to be used to secure it to the larger wing. This is made to so the wing can be put together and disassembled, reassembled, disassembled at the foundry. Once all the pieces have been cast, then the wooden wing is assembled in its entirety next to the metal wing that will evolve and be built up. We drop all these plumb lines and we do all the measurements from the wood original as we are welding the final metal sculpture together. This is what triggers my imagination, is this wonderful, wonderful wing. And and what we're dealing with, what we've just done, there's a number 5 secondary feather right here that we've been working with, and in my interpretation, here it is right here, number 5 right here, and it goes in right here, and you can see the scale, you see all the male and female plugs up in here. And what I'm going to do now is I'm going to insert and place the number 5 feather that we've just made up here, that you can see it fits. These are numbered backwards, 9, 8, 7, 6, and number 5 goes right here. And you can see I have the numbers burned into the wood, And those numbers will be cast, and so that when we put this together in the metal, there will be an indicator and a number right there to so that won't get number 5 and the number 6 hole. So see, the next one goes here right on up, and you can see how they fit together. What's interesting is once all this is cast in metal, when we go to put this back together, these indicators make it so much simpler, because everything's already positioned. All we have to do is put these. You have to remember, all this will be stainless steel, and once we put them in, all we have to do is weld around here to join it to the major part of the wing. And of course, all this will be disassembled at the foundry, so each piece can be molded and cast. What I'm able to do, and you can see these pegs, these corresponding pegs. Go right there, see? That's what hides all this. You see, that's how simply that goes, and that's in metal, and then this edge right here is all welded together. This is the original scale that I worked from and worked on, and this is what Rob and Paul Beatty scanned and gave me this back in its rough form, and then I detailed it. But it's so much easier for me to work into this scale right here rather than me to initiate and begin at this scale, because of the wood and me trying to shape this to exactly fit into this space would be just so time consuming.
We assembled the wood original out on the site on a homemade Lazy Susan. This thing could be turned around and moved around and oriented. And we made a record of that when it was exactly the way he wanted it. We pulled a line, took a compass, got an exact bearing so that we could put this thing back in stainless in the pool, oriented the way that Grainger wanted it. This wood base that the wing sits in right now was a model for the metal base that we would build later. We had an aerial photographer come in and give us some aerial photographs of this little peninsula where the wing was to be installed. Grainger wanted to decide where that was going to be located, and as soon as this decision was made and the landscape architect and Grainger and all got busy on this pool, the foundry was working at the same time on mold making and getting the base made. So there was a lot of work going on simultaneously. All the plumbing had to be in the correct place. Everything had to be oriented correctly. This is such a stretch from the very first time we went out there. There's a ton of work done, and all these walks and this pool. Tremendous amount of work going on that all has to come down to this one spot, this one place where this wing sits. All of this is what they call the lost wax process, and they call it that because you lose the wax in the process when the mold is made. He puts liquid rubber that gets all down into the detail of that surface. They construct what they call a mother mold, and that is generally plaster. They have plaster and some sort of reinforcing. I've seen burlap, different kinds of excelsior-looking materials all mixed up in plaster like you put a cast on a person. She has a completed mold that they put wax in, and this strap holds the two halves of that mother mold together. They break this apart. Inside is the wax. She's breaking the mold itself out of the mother mold. Up on the top is wax, that wax represents one wood feather. It's as close as you can get to reproducing that original feather in wax. The little squigglies around the side are vents to allow the wax to flow into that mold. So now this is the wax spruing step. Now they want to connect a way for metal to flow into that feather. When all of this goes into the ceramic shell mold and the wax is removed, you'll have a void left everywhere that this wax is now. Everything that you see now in wax will be a hollow cavity, and metal will flow into that. So they have to know where to connect all of these pieces of wax all the way back up to a funnel shape, which right below her hand, where the metal will pour in. This is ceramic shell department. This man dips the wax into a binder to get coated all over the wax. He goes from there to a tub of sand that has air injected in from the bottom. It allows him to dip this. What he's trying to do is build up a shell around this wax and capture all the detail that he possibly can. He holds it in every direction to get the binder to flow everywhere. They hang that, let it dry, they'll come back, dip it in the binder again, dip it in the sand again. They build up a thickness that they call the ceramic shell. Now you want to remove all the wax and you want to fire the ceramic. We can see wax dripping out the bottom there. Don't want that so hot that everything catches on fire. You want the wax to just melt and flow out of that ceramic shell. Once you start this, there's no stopping. They've got to continue to increase the temperature of these shells. The metal is going to be a couple of thousand degrees, and this shell has to be close to that so that it doesn't crack or shrink. This is coming out of the furnace into a container. Now this is an actual pour of melted stainless steel. That's pouring into the ceramic shell. Now the ceramic shell is broken away, and that's a stainless steel casting of one of the feathers. You see all those wax shapes that were connected are now cast in stainless as well. When they get this shell out of the way, they're going to have to chisel and saw and torch to remove all of those channels. It's a responsibility of the foundry to remove their parting lines where the two halves of the mold came together, all of their little gate connections. They have no way of knowing Grainger's requirements as far as texture and so forth. They do know that any little imperfection in the wax or in the metal is their responsibility. So this is one of the foundry guys removing little issues. The assembly is going to two of the major parts. This area can be welded, it's not going to be seen. The next feather will cover over. One of the comments that folks at Foundry made was how well thought out this process was and how he indexed. He had an index mark that showed where all of the original wood pieces went together, and that information gets transferred into wax and it gets cast in the metal. So it gives you a way to line things up. There's always a certain amount of shrinkage in wax.
I don't know if that needs this should be flat too.
There's also a little bit of shrinkage in metal. Theoretically, all this stuff should just fit perfectly. If the wood went together perfectly, the metal should go together perfectly, but there is still shrinkage, and so Some of these alignment holes have to be opened up a little bit, or pins may have to be changed just a little.
Just a quick dip over and it's gone. Okay. By the time you see it, it'll be fine. Fair enough. Better to ask. Yeah. This one's ready to.
There was a process on each feather that Grainger liked. He wanted a particular grit of sandpaper run on all of the surfaces, different buffing pads used on certain surfaces, and of course everything was sandblasted at one point. All of that work was done before any of these were welded together. And if those welds show, then somebody's got to go back and cut all that detail back in.
You will actually flip it over for me?
There's a kink in the end of a feather. There are pieces that are going to have a little curve that doesn't belong there, and it gets cast that way. You have to bend it back out or grind it back out. That's a buffing pad. Those come in a lot of different textures. You can get very coarse down to very, very fine. There are areas that Grainger wanted very fine, areas that he did not.
Good, my friend. You ready to go sky high? Yeah.
And it would remind you of roofing, where one shingle gets nailed and then the next shingle covers it. These have to be done in order. This is on the original wood model that they dropped this plumb line down to compare it as they assemble. Before he welds this feather in place, he wants to know that the top of it is over the same point on the ground as the wood original. So we have the wood original right there that all of these molds were made from and all the casting was made from, so that's what we want the metal to duplicate. The Grainger is very particular about trying to get the metal assembled as closely as possible to the original wood. Wing has been assembled. It's being moved out. Grainger wanted it out in the sun. That's where it's going to be in its final display. He's got a pad running around highlighting little particular areas. That's bolted to a pallet. A forklift will pick that up and put it on a truck and bring it to Swan Lake. The only difference between now and when we last saw it at the foundry on that pallet, they have a process called passivation, where they bathe this whole thing in acid. And that is just in case there's any place that it's been touched by ferrous metal. You don't want that to rust later. Don't want any grease, don't want any metal to touch it anywhere in this process. So all these straps have to be clean. The issue now is how to pick it up and place it into the socket. That socket is the same socket that the wing was assembled in. So we know this is going to fit. Grainger spent about a day out at our shop trying to get this connection exactly the way that he wanted it. A couple of set screws that snug this into the socket to be sure it doesn't wiggle around. They kidded us at the factory about how heavy duty this is. All of this was designed to withstand, I believe, about 100-mile-an-hour wind, maybe more.